Good evening, everyone. I'm Shwetha Varshini, pursuing my BTech Chemical Engineering from IIT Madras, now an MRC research intern. Happy to present my final presentation on the topic underwater radiated noise management. Okay, putting it in simple words, in this research, the studies goes from what we have and done so far to what should or can we do more regarding the URN management. So, starting with the area of applications, URN management has various area of applications, which include scientific research, waterways transportation, military, and offshore energy sector. And we have two interventions to be discussed here: technological interventions and policy interventions. Uh, Diving deep into the technological interventions, I have listed down some six major technological interventions that I feel it's important. So, starting with source path receiver analysis, which utilizes modeling and stimulation to analyze the entire acoustic pathway from noise sources such as ships or industry activities through water to the receivers, marine organisms or habitats, helping to pinpoint the critical noise transmission routes. Secondly, we have noise reduction technologies, which includes innovations like wider propeller designs, engine modification, and hull coatings that aim to reduce the overall noise emissions from marine vessels and installations. Also, we have active and passive noise mitigation methods and retrofitting noise reduction devices and etc. Then we have marine spatial planning, which involves zoning and regulating human activities in marine environments to minimize acoustic impacts on sensitive habitats and species, thus strategically managing noise sources. Next, we have real-time monitoring, which uses acoustic monitoring networks to continuously track underwater noise levels, providing timely data for immediate intervention or adjustment in operational practices. Next, we have habitat restoration, which involves using artificial reefs and bioacoustic devices. These actions attract and rebuild the marine population of the identified locations. Next, we have stakeholder engagement, which involves platforms like online forums, webinars, and interactive map foster discussion and data visualization, which enables transparent information sharing and collaborative problem solving. Also, we have social media and online campaigns, which can leverage the power of online communities to raise awareness and conduct a targeted outreach and gather valuable data through crowdsourcing initiatives. Moving on, we have challenges in imposing these technological interventions. First, we have technological complexity. Next, cost and implementation. Many noise reduction technologies can be costly to develop, install, and maintain, particularly for retrofitting existing vessels or industrial facilities. These can deter widespread adoption without financial incentives or regularly support. Then we have monitoring and data access, the challenges and regulatory policy framework implementation challenges. Then we have public awareness and stakeholder engagement as a challenge, and we have adaptability and innovation. Here, as technologies evolve and new noise sources emerge every day. So, example, we have renewable energy installations and marine mining. So, maintaining phase with these innovations and adapting management strategies accordingly is essential, but can be more resource intensive and time consuming. Next, we have policy interventions. Firstly, we have IMO guidelines. The International Maritime Organization (IMO) sets guidelines and regulations to control and reduce underwater noise from commercial shipping activities, promoting quieter vessel designs, operational practices, and routes to mitigate impacts on marine ecosystem. Secondly, we have Sustainable Development Goals (SDGs). SDG 14, Life Below Water, specifically targets reducing marine pollution, including noise. Policies aligned with SDG aim to integrate noise management into broader marine conservation and sustainable development agendas. We have marine spatial planning again. So, policies for marine spatial planning establish zones and regulations for human activities in coastal marine environments, aiming to minimize underwater noise impacts on sensitive habitats and species. Next, we have national environmental legislations. Like many countries have specific environmental laws and regulations that address underwater noise pollution, setting standards for noise levels, mitigation measures, and monitoring requirements in marine environments. Last, we have fisheries management plans, like which includes noise management consideration into fishery management plans, which helps us mitigate effects on the fish populations and their habitat, ensuring sustainable fishing practices while minimizing the distance from noise pollution. Next, we have challenges faced when imposing these policy interventions. We have international coordination, regulatory complexity, industry compliance, and monitoring enforcement. Also, we have scientific uncertainty. Understanding the ecological impacts of underwater noise across different marine species and ecosystems remains a challenge, hindering the development of evidence based policies and adaptive management strategies. Also, we have public awareness and stakeholder engagement. Building a public awareness and engaging diverse stakeholders, including industries, communities, and conservation groups, in policy development and implementation is crucial, but can be again resource intensive and complex. Now we come to the URN management in freshwater systems, which is something got less attention comparing to the URN management in marine systems. So I have listed some major challenges faced in URN management and freshwater systems, starting with limited escape for freshwater animals. Like unlike vast oceans, freshwater habitats like rivers and lakes are confined spaces. When URN pollution occurs, the freshwater animals often have limited options to escape the noise source. Factors like river currents, obstacles, or swimming grounds can further restrict the movement for some species, making them even more vulnerable to the chronic noise exposure. This restricted movement compared to marine animals makes URN pollution a more significant threat to freshwater populations. Next, we have complexity of river environments and limited research and data collection challenges and competing interests. Like freshwater resources are crucial for various uses like transportation, irrigation, and recreation. So, balancing these needs with noise reduction can be challenging. Next, we have enforcement and regulation challenges also. Implementing the and enforcing regulations on noise levels in freshwater systems can be complex, and especially across jurisdictions or with limited resources. Moving on, we have more concern on river dolphins when we have when it come to URN management in freshwater systems. Here we will be answering the question why it is. So, firstly, we have vulnerability to URN. So, river dolphins rely heavily on the sound for navigation, communication, and their basic needs. So, which makes it vulnerable to disruptions caused by underwater radiated noise. Secondly, its role as bioindicator species. River dolphins serve as bioindicators, offering insights into the overall health of the freshwater ecosystem. Their decline often signals broader environmental issues such as pollution and habitat degradation, and its cultural and spiritual significance and conservation challenges. Like most of the river dolphins have been identified as endangered and critically endangered species by ICU Red List of Threatened Species. So next we have economic benefits of conservation. Conservation efforts aimed at protecting river dolphins can have economic benefits through sustainable dolphin tourism. Well-managed tourism can generate income for local communities, providing a direct incentive for conservation efforts. Then we have awareness and education and legal protection. Many river dolphin species are protected under national and international conservation laws and agreements. Implementing and enforcing these protections are crucial for their survival. Also, we have integrated conservation strategies. Effective conservation strategies for river dolphins require integrated approaches that address multiple threats, including URN, habitat loss, pollution, and etc. Moving on, here we will be seeing the focus points for future plans. So, starting with standardizing regulatory frameworks across jurisdictions and bringing regional policies, need for more study on biological criticality of aquatic life, quantification of impacts, which can act as a concrete evidence for policymakers, then integration of technological and policy interventions, species specific researchers for URN effects, and of course, rising awareness. And below, I have listed down some future focus points for specifically for freshwater systems. Starting with research beyond freshwater dolphins, mostly we have the researchers are on the freshwater dolphins. We have a need to extend the research beyond freshwater dolphins to other species. Next, we have future plans on inland water transport. So many developing and developed countries have started and extending their future plans on inland water transport. So it is important to consider and understand the URN management to make sustainable development. Next, we have building spatial planning frameworks for inland waters, exploring naturally available options of noise mitigation. This is about the forest and the mangrove forest. Seems like an option for naturally noise reduction in the along the rivers. So this is something we have to look into and explore these kind of naturally available options. And we have more studies to picture sound propagation in inland waters, then need for regulatory frameworks by authorities in freshwater systems. So concluding my presentation with a motivating quote: the best way to solve a problem is to solve it. Thank you.